Today in this lecture we will learn about the wave nature of electromagnetic radiations. The next topic of the chapter is wave nature of electromagnetic radiations. What do you mean by the wave nature? As there are different types of the rays which emit through the source. These rays are either alpha rays or beta rays, gamma rays, visible rays, ultraviolet or the infrared. All these radiations are known as electromagnetic radiations. The word electromagnetic is made up of the two words electro plus magnetic. It means these radiations consist of the electric field as well as magnetic field. There is some common behavior of all the electromagnetic radiations, that is, all the electromagnetic radiations emit energy in the form of waves. These all radiations, either alpha rays or beta or gamma or the visible rays or ultraviolet rays, all these radiations emit energy in the form of the waves. Next property of the electromagnetic radiations are these rays consist of electric field as well as magnetic field. These radiations consist of electric field as well as magnetic field, and this electric field and magnetic field are perpendicular to each other as well as they are perpendicular to the direction of propagation. And the next property of these radiations are these all rays travel with the velocity of light, and the velocity of light is 3 into 10 raised to power 8 meter per second. Means all these radiations, their velocity is constant and they are moving with constant velocity, that is 3 into 10 raised to power 8 meter per second, which is the velocity of the light. And the last property of these radiations are they don't require any medium for traveling. They don't require any medium for their propagation or for their traveling. These are the some properties of electromagnetic radiations. First property is these all radiations emit energy in the form of the waves. Next, they consist of electric field as well as magnetic field. Therefore, they are known as electromagnetic radiations. Third property is they travel with the velocity of light, and last property is they don't require any medium for their propagation. Now, the keywords related to the wave nature. Let us consider the simple wave. This is wave or the wave character of the electromagnetic radiations. This is known as the origin or the axis of the radiations. The upper part of this wave is crust and the lower part of this wave is known as trough. The first definition of wave is wavelength. First definition is wavelength. It is denoted by the letter lambda. It is known as lambda. How do we define the wavelength of a wave? As its name suggests, length of one wave. Wavelength means length of one wave. How do we define wavelength? Wavelength of a wave is the distance between two successive crusts or the distance between two successive troughs. Either it is the distance between two successive crusts or distance between two successive troughs. It is known as the wavelength or length of one wave, and it is measured either in picometer or in Armstrong or in nanometer. It is measured in picometer, in Armstrong or in nanometer. 1 picometer is equal to 10 raised to power minus 12 meter. 1 Armstrong is equal to 10 raised to power minus 10 meter, and 1 nanometer is equal to 10 raised to power minus 9 meter. Similarly, micrometer. 1 micrometer is 10 raised to power minus 6 meter. These are some units to measure the wavelength of a wave, and wavelength is the distance between two successive crusts or two successive troughs. Next term is amplitude. Next term is amplitude. How do we define the amplitude of a wave? Amplitude is defined as either the height of the crust or depth of a trough. Either the distance of the crust from the axis or depth of the trough from the axis is known as the amplitude of a wave. Generally, amplitude of a wave is measured in centimeter. Generally, it is measured in the centimeter. Either it is the height of the crust or it is depth of the trough, and it is defined as the height of the crust from the axis or depth of the trough from the axis is known as amplitude. Next term is frequency or frequency of a wave. Frequency, it is denoted by the letter nu. This is the symbol of the frequency, which is known as the nu. How do we define the frequency of a wave? Let us consider any fixed point on the axis. This is the fixed point on the axis of the propagation of the wave. Frequency. How do we define the frequency? Frequency of a wave is the number of the waves passing through a point in 1 second. Means the number of waves which are passing through this point in 1 second is known as frequency, and the unit to measure frequency is 1 upon time. As frequency is the number of the waves, we know that number has no unit. Number of waves passing through this point in 1 second. 1 second means the unit of the time. So its unit is second inverse, and second inverse is known as hertz. Either you can write the second inverse or you can write the hertz. SI unit of the frequency is hertz. Next is wave number. Next is wave number, and wave number is denoted by the nu bar. This is the symbol of the nu bar for wave number. How do we define the wave number? Wave number is the number of waves present in 1 centimeter distance. In 1 centimeter distance, the number of waves which are present is known as wave number. Wave number are the number of waves present in 1 centimeter distance. As 1 centimeter is the distance or the length of the wave, so mathematically it is calculated as 1 upon lambda, or it is reciprocal to the wavelength, and its unit is either centimeter inverse or picometer inverse or Armstrong inverse or micrometer inverse. The unit which has wavelength, its unit is inverse of the wavelength. If it is measured in centimeter, then the unit of wave number is centimeter inverse. If it is measured in picometer, then unit is picometer inverse. If it is measured in Armstrong, then its unit is Armstrong inverse. Similarly, if it is measured in micrometer, then its unit is micrometer inverse. And last one is the velocity of the wave. As all the waves are traveled with the velocity of the light, so the velocity of all electromagnetic radiations is 3 into 10 raised to power 8 meter per second, which is the velocity of the light. There is relationship between frequency and wavelength of a wave. It is found that the product of wavelength and frequency, it is always equal to the velocity of the electromagnetic radiations, or C is equal to lambda into nu, where lambda is the wavelength of the wave and nu is the frequency of the wave. When we multiply these two terms, wavelength and frequency, the product of these two is always velocity of the light, that is 3 into 10 raised to power 8. This is all about the wave nature of electromagnetic radiations.